To determine the volume of a cone using integration, the volume of a cone is given by, or the volume of cylindrical object when they are rotating in the x-axis is given by volume x, which means they are rotating in the x-axis, the integral from a to b y squared dx. So if that is the case, we need to find the gradient or the equation of the line from this point to that point, which we can call OA, and this point can be called B. So if that is the case now, how do we determine this line? Remember, the equation of a line is y is equals to mx plus c. So if that is the equation of the line, we need to determine c. We also need to determine the gradient. So how do we determine the gradient? Automatically from the equation or from the graph that we have been given, we are able to see that the c, which is the y-intercept, is equals to 0. So you can say c is equals to 0 because it is passing through the origin. Now, how do we determine the equation, or how do we determine the gradient? So from the information given, we know to say this point there is 0, 0, and this point is 21,7. We are able to determine the gradient using the method m is equals to y2 minus y1 divided by x2 minus x1. If that is the case, meaning our first coordinate is 0, 0, and our second coordinate is 21,7. So if that is the case now, we can determine the gradient by saying m is equal to 21 minus 7 over, 21 minus 0, because this is, we can say m is equal to, this is our y2, x2, y1, x1. So we can say 7 minus 0 divided by 21 minus 0. If that is the case, we can say 7 over 21. So if that is the case, this is the same as saying m is equal to 1 over 3. So this is the gradient of the line. So if this is the gradient of the line, we are able to see that the equation y is equals to mx plus c becomes y is equal to 1 over 3 x. We can't say plus 0 because 0 means nothing. If you want, you can say that, which is the same as saying that. So this is the equation of the line that we are determining, this line there. So if that is the case now, we can determine the volume. So how do we determine the volume? You say volume in the x-axis is equal to pi. If that is the case, we are integrating with respect to x, and if you check, our limits in the x-axis is from this point to that point. These are our limits. So this point is 0 and that point is 21. So we are saying from 0 to 21. If that is the case, here we have y, which is y. Now remember y is equal to 1 over 3x. So it will be 1 over 3x, then you square. If that is the case, dx. Now, so we have the variable x and we are integrating with respect to x. So this implies that volume in the x-axis is equals to pi. The integral from 0 to 21 is equal to, if you square that, it will give us 1 x squared over 9. Then you say dx. Now, if we integrate this, we say volume x pi, the integral of this is 2 plus 1, which is 3. 3 multiplied by 9, it will give us 27. So it will be over 27 there. Then this will be 1x power 3. So if that is the case, we are going to have limits from 0 to 21. So if these are our limits, this is what we can say. Now we can determine the volume by saying that is equals to pi, which is equal to, so we are replacing x by 21 power 3, you divide by 27. Then if that is the case, we know to say this side again we have pi, then we have 0 power 3 27. So if that is the case, we are going to have x equals to pi, open bracket, then this is the same as saying 21 raised to the power 3, and it is giving us something like 9261 divided by 27. So if that is the case, this divided by 27, it will give us that, which is equal to 343 multiplied by pi, and that is equal to multiplied by 3.142. It will give us 1077.706 centimeter cube. This is the volume of a cone using the method of integration.